Danny. Danny's gone. Danny.
Hi, Danny.
Hi, Danny.
Yeah. Hi, Danny. Hope you feel better. All right. So your first goal today, actually most of the kids got their assignments done today in class. You'll hopefully be able to have that opportunity. We want to be able to rewrite degrees into radians. That's the first thing that we're going to do. So, for example, 0 degrees is the same as 0 radians. We've already talked about it. We'd like you to be able to do it without looking at the chart. Who remembers what 30 degrees is as a radian? Pi over 6. Okay. Now, sometimes you might get one that we haven't talked about. For example, 105. That's not one we've talked about, is it? So your conversion to go from degrees to radians is as follows. Your conversion is to take theta and multiply it by pi and divide it by 180. So if you see 105 degrees, we convert that to a radian. We have 105 times pi, and we divide it by 180. Now we go back to Lily's point earlier about reducing. Does 105 over 180 reduce? It does. What are they both divisible by?
5.
We for sure see 5. So we divide by 5 and we get 21 pi over 180 divided by 5 is 36. What are 21 and 36 both divisible by? 3. So we get 7 pi over 12. 7 pi over 12. And that's the answer I'll look for. But then you might get one that you know quite well. 240. We practice 240. 60 goes into 240 4 times. So it's going to be what?
4 pi over 3.
4 pi over 3. Do you remember what 90 was?
Pi over 2.
Pi over 2. We could have negative angles. We'll talk about negative later on, but it will be a negative amount. 135, how many slices of pizza is 135 degrees?
3.
It is 3 pi over 4. Uh-oh, 450. That one has not popped up for us. So I take 450. I multiply by pi. I divide by 180. What are both divisible by?
90.
90. If you take 45 or 450 divided by 90, we get 5. And 180 divided by 90 is 2. We get a 5 pi over 2. And finally, negative 300. Negative 5 pi over 3. Thank you, Mr. Bryant. Not too bad.
No.
So on your assignment today, you're going to be looking to convert from degrees to radians. You also do radians to degrees. I'll show you how to do one of those. And then the last thing is going to be looking to sketch angles in standard position. So this is a little bit newer for you. Okay. So we'll do 5 examples here of sketching an angle in standard position. And standard position means that we are going to take the XY axis as a coordinate plane, and we're going to put an angle on there. The angle has 3 parts to it. It has the initial side. The initial side of every angle goes on the x-axis on the positive side. So that's where every angle will start. The terminal side then creates the shape of the angle. So that's approximately a 42-degree angle. We rotate that shape counterclockwise into quadrants 1, 2, 3, and 4 in that order. Okay? So make sure you have the initial side, make sure you have the terminal side. And then to show that we rotated that direction, you do draw a little arc, just like that, with an arrow pointing that that was your rotation. Okay? Because what's different about the next one? It's negative. What do you think we do if it's negative?
Rotate the other direction.
You rotate the other direction. So I'll continue to draw my XY axis. And I put the initial side right on the x-axis, the positive side. If it was positive 113, which quadrant would you end up in?
2.
You'd end up in the second, right up here, right? So if it's negative 113, you're going to end up in the third quadrant. And so you draw your rotation like that. So again, you need to draw that arrow showing your rotation. And it doesn't have to be exactly 113 degrees. You don't have to get out a compass and a protractor and do that measurement. Just a general description, okay? 4 pi over 3. What's different about this one's a radian. Most people will take that radian and they'll convert it into a degree. And the way we convert to degrees is we don't multiply by pi over 180, we multiply by 180 over pi. When you do the conversion of radians into degrees, what do you notice happens? The pi's do reduce. And if you saw the pi over 3, your brain should be drawn to 60 right away. Notice that 180 divided by 3 is 60. And then times 40 will be, times 4 will be 240 degrees. So we just want to draw an angle of 240 degrees. And that will place us into the third quadrant. Letter D. Is that an angle? I'm sorry, is that a radian measurement or is it a degree measurement?
Radian.
But it doesn't have a pi attached to it.
Does it have a degree?
Doesn't have a degree symbol, does it? Doesn't matter if it's a decimal, okay? It could be a radian. It's just fine. The fact is that it doesn't have a degree symbol, so therefore it's a radian. It's not expressed in terms of pi. I'm actually going to graph this one without turning it into a degree. You sure could, but it's not that bad to sketch it without turning it into a degree. I'm going to show you what that looks like. If instead of putting, say, 0, 90, 180, 360, so on and so forth on our chart, if we write the radian measurement, we have this is 0, and this would be pi. And pi is the same thing as 3.14. I'm doing this because you should get comfortable with the decimals as well. If I go half of 3.14, you get 1.57. And then if you go 3 pi over 2, you get 4.71. 4.71. So suppose it wasn't a negative 4.6. Suppose it was a positive 4.6. Which quadrant would you end up in?
2.
You would end up in the third quadrant, very close to the 4.71, right?
If it was positive.
But because it's negative, instead of rotating like that, I'm going to rotate this and I'll end up in the second quadrant. So again, I'll draw it out. If you were to do positive 4.6, you'd be right there. But it is not positive, it's negative. So I'm going to be right there. So that's my rotation. And finally, what's different about the last one? It's bigger than 360. How much bigger than 360 is it? 60 degrees more than 360. So if I draw my angle, I can draw a 60-degree angle here. But as I show my my turn, I'm going to go around the circle more than once. Rosa got really excited when we drew that. So that was kind of like arts and crafts time at that point. So that's sketching angles, and that's turning them from radians to degrees, and degrees back to radians. Please take out your homework assignment. Let me show you how to get started on that. If you open your first page, the first directions say to convert from degrees to radians. So I just want to make sure everybody understands. So the very first problem is 140 degrees. So you're simply going to multiply by pi and you divide by 180. Please try to do it without a calculator. If you have to go to a calculator, so be it. But what do you notice that they're both divisible by? 10. So you get 14 pi over 18. And then 14 and 18 are both divisible by 2. So you get 7 pi over 9. If you could do it without a calculator, it would be to your benefit. Look at the next section. The next section says to convert from radians to degrees. And so is it 2 pi over 5 or 3 pi over 5?
3 pi over 5.
So here you get 3 pi over 5. And in that conversion, we multiply by 180 and we divide by pi. You'll notice that the pi's do cancel. And then if you can't do it without a calculator, then that's fine. But 3 times 180 is 540. 540 divided by 5 is 108 degrees. And then on the back side of that page, you're going to be sketching angles in standard position. So you guys have the rest of the hour. The answer key is posted right up here.